Question 11's standard form, straightforward standard form question. They want us to write 60,800,000 in standard form. The standard form needs to be a number between 1 and 10. So that's going to be 6.08 for me. Times by 10 to the power of however many decimal places you would need to get back to your original number. So I'm saying I want my decimal point there. So how many decimal places do I need to multiply by in order to get back? 1, 2, 3, 4, 5, 6, 7. So it's to the power of 7. Don't make the mistake of just counting the zeros and then putting that number in, because that doesn't work. Part B wants you to write that number that's given in standard form as an ordinary number. Now the fact that this has got a negative power of 4 means that the answer is going to be a 0 point answer. So I need to work out now what it would be if it was 1.7. And because I'm taking away 4, I need to move it back 4 decimal places. 1, 2, 3, 4. So I'll drop it there and I'll fill each one of these spaces with a 0. So my answer is actually going to be 0.00017. Oh. And that's 1 mark question each. 2 marks for standard form. Nice and easy. Question 12, some nice algebra questions. 12a is factorise e squared minus 100. Now this is all about spotting something called the difference of squares. It's called the difference of squares because e squared is a squared number and 100 is a square number, and you're taking them away from each other. So it's difference of squares. And the difference of squares go into double brackets where you have the root of the first square plus and minus the root of the second square. So the root of 100 is 10. That's a rule, you just need to learn it. You can do lots of practice, ask your teacher for some practice on it. And that's just 1 mark. Part B is factorise, and you've got a 3-part quadratic expression. So that also goes into double brackets. Now the fact that one of them starts with a 2x, the fact that there's a coefficient there, means that one of your brackets starts with 2x and the other one starts with x. Now that is a negative 15, and my numbers, whichever 2 numbers I pick to go there, have to multiply together to give me 15. They then have to plus or minus each other to get 7. So the fact we've got a negative product there, a negative 15, means my signs have to be different. So one of them's going to be positive, one of them's going to be negative. I was going to go then and put the positive there and the negative there just because that's what I do when there's no coefficient. But I realise there's a coefficient, so I can't take that shortcut. I can't just cut that step out. So let's have a think. I can identify the numbers. I need to get to 15. There's only 2 ways of getting to 15, and that's 1 times 15, which can also be written as 15 times 1, or 5 times 3, which can also be written as 3 times 5. So I've got to decide which numbers go in these spaces. Now, whatever number I put here, it's important to note whatever number goes there is going to end up getting multiplied by 2. So when we're thinking about them adding together to give us that 7x, negative 7x, we need to remember that that value is going to be doubled. So let's try it. Let's see, what would it be if that was 1 and that was 15? They would times together to give me 15, fine. But what would they add to? So there'd be a 15 there. The 15 would get doubled, so that would be 30. It doesn't matter whether it's positive or negative. The fact is it would be 30 and we'd be adding on or taking away 1. That's never going to get us to where we want to be. So it can't be that option. So here, if I had 15 and 1, that would become 2. And there's no way between 15 and 2 I can get a difference of 7. So it can't be that. Now I'm down to my 3 and 5. Where I put the 3, where I put the 5, and where I put the positive sign, where I put the negative sign is going to be responsible for getting me these 2 marks. However, if you really cannot do that and you can't process the thought of doing all this work, then as long as you put a 3 and a 5 and a plus and a minus with either of them, you'll probably get a method mark, because you've shown the knowledge that they have to times together to give you negative 15. But let's do this properly. Let's think about it. If I had a 3 there and a 5 there, this would end up being doubled to get 10. And if I've got a 3 there and a 10 there, I can manipulate those numbers in order to get to the negative 7 I want. So they're the numbers I'm going to use. And I'm going to say I want a positive 3 and a negative 5. The reason I'm choosing the big number to be the negative is because there's a negative product. Okay, so what I'll get here is 2 lots of negative 5, which would be negative 10x. And then I'd have an add 3x. So I'd have negative 10x plus 3x would give me negative 7x. Now, I'm not going to take my own word for this, because I might be wrong. Remember, I'm in an exam and I'm under pressure. So let's expand those brackets out. 2x times x would be 2x squared. 2x times negative 5 would be negative 10x. Positive 3 times x is plus 3x. Positive 3 times negative 5 is negative 15. Collect my x terms. Negative 10 plus 3 gives me negative 7x. I've got a 2x squared there and a negative 15 there. Was that my original question? Yes, it was. So I know I can leave that exam with 2 marks there. Part C is deceivingly complex looking. It says simplify, and then you've got these algebraic fractions with powers, and you think, oh, how do I multiply out a bracket that's g minus 7 to the power of 9? You can't do it. Okay? When I say you can't do it, I mean, of course you can do it, but, whoops. But this question is only worth 1 mark. That's your clue that it must be something straightforward. And it is. It's just index laws, but disguised as something way more complicated. Here we've got g minus 7 to the power of 9, and here we've got g minus 7 to the power of 3, and I'm dividing them. Now the rules of indices state that if something's raised to a power of something, it can stay as it is, and you just amend the power. So 9, something to the power of 9 divided by the same thing to the power of 3. If we're dividing, it means we need to subtract the powers. So you end up with g take away 7 to the power of 6. And 13 wants you to rationalise the denominator. What they mean by that is they want you to get rid of the square root at the bottom of that. So I'm going to write it out so it's bigger and the camera can focus on it. 3 to the power of root 7. Now, if I times anything by 1, the value of itself stays the same. And if I want to get rid of a root, then I can just multiply it by itself. So what I want to do is root 7 times root 7. Now I can't just multiply this by root 7 and ignore the top. So I'm going to multiply the top also by root 7. So what I end up with here is 3 times root 7, which is 3 root 7, divided by the root of 7 times by the root of 7, ends up giving me 7. So my answer is 3 root 7. And it's a 2-mark question. You get 1 mark here for showing that you know to multiply by the root as a fraction, and then you get your answer mark for having the right answer. Now if you can't follow the idea that root 7 times root 7 gives you just 7, let's pretend that it was root 16 times by root 16. Now I've picked 16 because it's a square number. So the root of 16 is 4. The root of 16 is 4. So if I do 4 times 4, I end up with 16. And that's why that rule works. Okay, root of 16 times root of 16 equals 16. Root of 7 times root of 7 ends up giving us 7. Question 14 is a circle theorem question. And whilst it looks pretty nasty because of all these lines inside it, it's one of the more simple circle theorem questions I've seen. However, it does have a set of parallel lines, so it expects you to know the angle properties of parallel lines. So you may need to go away and revise that before you have any understanding of what's happening here. So there's the diagram. AB is the diameter of a circle. That's AB. It's got a centre of O. The point R, so that's there. The point R is on the circumference of the circle. RST is the tangent. Alarm bells are ringing. Tangent. Whenever I see tangent, I think 90 degrees. And I think 90 degrees with the radius. Alright, that's your clue. So I'll keep reading for now. So RST is the tangent to the circle. AS is parallel to OR. AS is parallel to OR. Prove. So they're not asking you to work anything out. They're just trying to get you to use the information you've got to show that the size of angle AST is 90. So there's AST. We need to prove that that is 90 degrees. Now you may be tempted to think, oh yeah, tangent, 90 degrees, that's my proof. No. A tangent has to meet the radius or diameter, okay, for it to be 90 degrees. And as if by coincidence, up here we just happen to have a radius, and there we happen to have a tangent. So that there is 90 degrees, and that's where I use this rule. So I'm going to make the statement that ORS equals 90 degrees because it's angles. No, it's not. Sorry. It's because a tangent meets the radius at 90 degrees. So that's 90 degrees. That's my circle theorem part dealt with. Now I need to look at the parallel lines. Now the fact that I've got a parallel line there, which I could with my ruler extend, and a parallel line there. They're my two parallel lines. And what I end up with here is two parallel lines with a line going through them. Now that means that with parallel lines, when one line cuts them, these two angles are the same, those two are the same, they're the same, and they're the same. And there's lots of different rules that you need to learn angles in parallel lines, so make a note of that if it's something you need to revise. I, however, happen to know that because those two angles are in the same place, they're both in the sort of upper left-hand corner, I know that they're called corresponding angles. So angle AST equals 90 degrees because it is corresponding with angle ORS because AS and OR are parallel. So I'm telling the examiner I've spotted the parallel lines and they are corresponding angles. It's a 3-mark question. You get 1 mark, so there's a B1 mark here for identifying that that'd be 90 degrees. You get a communication mark here for saying that the tangent meets the radius, and you get a communication mark here for showing the proof. Question 15 is a lovely algebra and area problem. So the diagram shows shape A. All the measurements are in centimetres. Find an expression in terms of x for the area in centimetres squared of shape A. You must simplify your answer. So there's shape A. That's a horrible shape to find the area of. What would be lovely is if I cut that into two other shapes. And I'm going to call that shape A, and I'm going to call that shape B. So first thing I'm going to do is find the area of shape A. And the area is base times height, remember, so it's got a base of 2x plus 2 and a height of x. I've put it in a bracket for the sake of it, okay? I need to expand that out. So I'm going to have x times 2 is 2x, and x times by 2x is 2x squared. That's a really awkward way of me writing it. I could have written x open bracket 2x plus 2, which is how you're used to seeing it. But either way you'd get the same answer. So that's the area of A. Now I'm going to find the area of B. And the base of B is x plus 2. And the height is x plus 1. So I'm timesing them together. So x times x squared, x times plus 1 is plus 1x. 2 times x is plus 2x. 2 times 1 is plus 2. So collect and simplify means I end up with positive 3x x squared plus 2. That's the area of B, that's the area of A. Now I'm going to find the total area. And I'm sectioning it off so the examiner can see what I'm doing. And the total area is x squared plus 3x plus 2. Add the 2x plus 2x squared. Now I'm going to simplify, so I've got an x term there, an x term there. So that's it for x terms. So I've got 5 x's. And then I've got an x squared term there and an x squared term there. So x squared and 2x squared is 3x squared. And then I've just got my number on its own, which is plus 2. So I've ended up with an area of 3x squared plus 5x plus 2. Is that, I was going to look back then and say, is that what they wanted? Is that what they wanted? And that's because this is usually a proof question. Sorry about that. That is the area. Alright, part B. Shape B. Now they haven't given us shape B. Don't be confused. Okay, they haven't given us shape B. Shape B is a rectangle. I'm going to just draw a sketch of a rectangle. So shape B is a rectangle. It has the same area as shape A. And my area was that, so I'm going to write it here. I'm also showing the examiner that I think that is the area for shape A, and I'm using it for part 2. So 3x squared plus 5x plus 2. Shape B has a length of 3x plus 2, so I'm going to call that 3x plus 2. Find an expression in terms of x for the width of in centimetres of shape B. So I need to find that, the width. Now this may look complicated, but it's easier than you think. I know that 3x plus 2 times by something is going to give me 3x squared plus 5x plus 2. So it's really just a question on factorising. I know to get from 3x to 3x squared, I would need an x term. And I know that my two numbers, they're both going to be positive, because here I've got a positive 2 and a positive middle number. And 2 times 1 is 2. So you're going to end up with 3x plus 2 and x plus 1. So find an expression in terms of x for the width. Well, it's going to be x plus 1.